Hi, good afternoon, Archini.
Good afternoon, sir.
Good afternoon. So, you send me the PDF file. Okay.
Yes, sir.
First, we should start with that Doppler, or we should take the doubts.
So, Doppler, I just had a doubt in one particular type of question.
Okay.
The
So you have sent.
echo type. I know the formula and how to use it, but
Okay.
for the echo type of question, I got confused.
So have you sent that question or Doppler question in this also?
No, sir, it's not there. Just a minute.
Okay. So send me that only. Emitting a frequency move away from towards a cliff. The frequency of sound observer hears the echo. Okay. Okay. Got it. So in this case, a siren. This is a siren which is emitting sound. So there is a cliff. There is a cliff. Okay. And here it's the observer. Here's the observer. Okay. And frequency of the sound emitted, sound that the observer hears in the echo reflected from the cliff is. Okay. So see, in this case, the sound they are saying that it is receding away, and it is emitting a sound of frequency 800 hertz. Okay, and it is moving towards the cliff with a speed 15 meter per second. Okay, this is given. This is given. Okay. So in this case, it is given that it is moving with 15 meter per second. So first, see, sound will reach on the cliff. Tell me.
Yes, sir.
And then from the cliff it get reflected and will reach towards the observer.
Yes, sir.
Okay, so first we have to find at what frequency the sound is reaching from the cliff to the cliff.
Sir, could you please repeat?
We have to find what is the frequency of the sound that is reaching to the cliff.
Okay, sir.
Because see, for cliff this source is moving. So cliff would not receive a sound of frequency 800 hertz. Okay, so whatever frequency will reach on the cliff, the same frequency will be get reflected back to the observer.
Yes, sir.
So see, for how can we find the formula is V plus V observer divided by V minus V source into frequency of sound. So our frequency of original sound. So it is 800, and V velocity of sound is 330. 330 you have to take or what? 330. And observer sound is in this case cliff. So cliff speed is, tell me.
So 0.
Okay, and V minus V source, and its speed is 15. So 330 minus 15. So this frequency is reaching towards the cliff, on the cliff, and the same frequency will be emitted because cliff is at rest. The same frequency will be reflected back to the observer.
Sir, there was another type of question which had the same thing, but in the end it was given what is the frequency observed by the driver itself. So we hear the observer changes to the driver.
So in this case, this is the frequency that is reaching towards the cliff. Okay, So what cliff will do? So cliff becomes a source now, and it is emitting a frequency this f. So this becomes source. This becomes source now, and we will apply just again same formula. In this case, what we will do? V plus V observer divided by V minus V source. And here f in this f, we will put this f.
Okay, sir.
Got it? This I will put. Okay. Clear?
Yes, sir.
Okay.
Sir, there was another method in which they directly substituted using the same values. Like instead of putting this f, they didn't do this double way. They assumed
they would have multiplied.
See,
they would have multiplied this. They would have multiplied this. They would have multiplied this. So here, in this case, this 330 and 330 would get cancelled out because source is now 0. So this source is 0 now. So over numerator is 330 and denominator is 330. But this is our final frequency. This is f1 and this is f2. We have to find f2. This is f1. So if we put the value of f1 over here, so what will happen? 330 and 330 would cancel out. So it will remain V plus V observer, which is.
But why would the okay, got it. So here the source will be the cliff, right? The second time in.
Yeah, correct. Okay.
Yes, sir.
Okay. Let me check now questions that you've sent me. Consider it. Already make this PDF. This is not. It is seeming like only 1 or 2 page. 5 page. Oh, okay. 11 pages are there. Okay. Consider current carrying wire in the shape of a circle. Note that as the current progresses along the wire, the direction of yes. So in this case, what is happening? That current is flowing in a wire. Okay, current is flowing in a wire, and what is happening? The J is changing. Okay. Produced by a charge accumulated on the surface of the wire. Let me check all the questions, then I will just see one by one. What is the answer of 79? What is the answer of 79? Tell me.
The B only.
B only. Electrode produced by charge accumulated on the surface of the wire. Because see, this is a wire. Let's suppose in this some current is flowing. I have made it somewhat bigger. So in this current is flowing. So in this case, current will give rise to magnetic field also. Okay. So magnetic field would be in which direction? Can you tell me if the current is flowing like this? So magnetic field would be because we can assume that current is uniformly distributed over the wire. So by the Ampere circuit or loop law, we can see that magnetic field here would be upwards and magnetic here at these point. This is the center line of the wire. So upwards point on the upward point, the magnetic field is towards us, and not the downward point, the magnetic field is away from us. Got it? Okay. So from this magnetic field, because electrons are also flowing, so they will experience force.
Yes.
So electron will the positive charge would get positive charge would be having here the positive charge will go here positive charge will go here, and here the positive charge will go like here. Okay.
Sir, why is it coming towards the center?
Because see, the positive charge is because see the forces on the positive charge is in this manner only.
Okay, sir. Good.
You got it. So we can say that here negative charge is being distributed from the negative charges are again the. Do you have the solution of this?
Sir, I have to check.
Okay, wait. Let me just you check then. I'm just checking the other questions also.
Yes, sir.
Okay, so the other question is this, that P1 bulb is this, and this is key, and B3 bulb is this, and P2 bulb is this. Okay. Yes, this is key K. So key K is closed. Okay, see, when key K is opened, B3 will get disconnected. B3 will get disconnected. B3.
Yes, sir. Yes.
B3 would get disconnected. So only B1 and B2 will remain.
Yes, sir.
Okay, see, they are identical bulbs. They are identical bulbs. So initially find the resistance of the. Okay, so let's suppose this resistance is R, this resistance is R, and this resistance is R. Okay, so see, in first this B2 and B3 are in parallel, and B1 is series with this. Okay, so B1 and B2 and B3 resistance is how much?
R by 2.
R by 2, and this is series, so the total resistance is 3R by 2. Okay, so the current is V divided by 3R by 2. The current that is flowing is V divided by 3R by 2. Okay,
Yes.
so it is 2V divided by 3R. Okay.
Yes.
Okay, so see, what is the voltage drop coming across this bulb? Now we have to calculate all the voltage drop.
The 2V by 3.
2V by 3. And what across this? Here V by 3R would going. V by 3R would be going, and here also V by 3R would be going. So how much drop is going? V by 3 and V by 3. Okay, so this is the voltage drop. And when this bulb is open, when the switch key is open, then the circuit is like this. B1. So B3 will, the brightness of B3 will go down. B3 will not glow.
Yes.
Okay, so this is B1 and this is B2. Okay, so here see, V by 2R current will flow because R and R, the effective resistance is 2R. So V by 2R current will flow. And what is the voltage across this? B1 drop. B1, I into R, V by 2 and V by 2. So see, across B2, the voltage has been increased. Okay, so B2 brightness will become more. And B1 brightness will decrease because here the voltage is now B by 2. Got it?
Yes, sir.
Okay. Equivalent between point A and B. Okay, that's In this, you can convert star to delta. Do you know the conversion of this star to delta? How do we convert?
No, sir.
Okay, this is because this we have to use in this case, or we can do it without doing that also. See, let me just draw the circuit first. This is resistance R. 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 This is R. This is R. This is R. Okay. So this is A and this is B. C. Tell me. Everyone is R. Okay. See, this resistance and this resistance are in. Wait. Okay. Okay. Let's see. The voltage over here is V. So what is the voltage at this point? Tell me.
Different V dash.
No. See, this is connected through a wire.
Oh, okay. V.
So V, and this is also connected. So here also V. So no current, voltage difference is same. Voltage difference is zero. Voltage potential difference is zero. Okay. So it will be zero. No current will flow in this. Okay. So here no current will flow. Okay. Now here let's suppose the voltage is V. So this we can omit. This we can just cut out. Okay. Okay. And then what else we can do? See, one more thing. Let's suppose this voltage is V. This is V dash. This is V dash. So here would be V dash, and here also. And let's suppose this voltage is V double dash, and this voltage is V triple dash. Got it?
So why would it change? There's a connecting wire, right?
Where?
Shouldn't it be V dash?
Where
instead of V double dash?
So between there is. Oh wait, correct. So it will be V double dash only. Correct. So no resistance, no current will go in this. So it is short.
No, sir. Instead of V double dash, the first time you wrote V double dash, shouldn't it be V dash itself?
Tell me what are you saying now?
Sir, after you've written V dash, you've written V double dash, right? Shouldn't it be V dash itself? Because there's no resistance in between.
Okay. So this is V dash. Okay. V dash. This is V dash, and this is again V dash. And yeah, this is also V dash. Okay. So let's suppose there the voltage is V4 dash. Okay. V4 dash. Okay. So see, this R and this R and this R, the voltage difference is same.
Yes.
So they are in parallel, everything. So this resistance would be R by 3 because both three are in parallel.
Yes.
Okay. And okay, so we can do it like this, that we can eliminate this branch. Okay. And we can connect a resistance R by 3 like this. Okay. And now what is the voltage V dash? Here V dash, here is again V dash. So this again is shorted now.
So these two are in series, so we just add.
Huh?
What did you ask?
What I'm saying that this voltage is V dash. So this is
yes.
Okay.
A short circuit.
Yeah, it is short circuit. Okay, so this is short. Okay, we can remove this. Okay, so now what is remaining? V dash, this we can short. And okay, this R and this are in parallel. This R and this are in parallel. So it will be R by 2 and this R and this are series. So R by 2 plus 2R. 5R by 2. Answer is 5R by 2.
Yes, sir.
Okay.
Let us send the answer to the first one.
Let me check. Okay, we'll see. That will put by the charge accumulated on the surface. But why are the charge accumulated? Why are the charges are accumulating on the wire? Okay, because we can say that negative charge and negative charge are accumulating over here. We can say like this, that I've told you, due to magnetic field, due to magnetic field of the wire. So due to this, electron over here would get repelled and they will move like this. Electron over here will repel, they will move like this. Okay, so see, so more density of the electron would be more over here in the center and less over here, less over here. So current density over here would be more and current density over here would be less. Getting? Tell me.
Yes, sir.
Okay. The direction of changes in exact manner. The current I. But here the direction is not getting changing. Current progress along the wire, the direction of current density changing in exact manner. Why the
Sir, is it because the current carrying wire is in the shape of a circle? So does that have to do with the change in direction?
No, we don't have to assume this. Okay, the
No, sir,
current
it's
can
given
be
the question.
okay. It is given. Okay, the current is carrying by this in the shape of the circle. Okay, so then direction would get changed. Direction would get changed. But still, direction is changing. Direction is always changing, or current density is also changing. Both the things are happening. Okay.
So the electric field that are produced, it changes the
Current
exerts
density.
of
It
force
changes the current
and
density. It changes the current density. So less electron would be at the periphery and more electron would be at the center. Okay. Yes. And lamps of Venus fed by a machine or a sensor, if light emitted by any lamp is proportional to the square of the heat produced. Question number 33 I'm solving. See first. A charged particle P leaves the origin with a speed V0 at some inclination with the x-axis. See, this x-axis, it is leaving with some inclination V0, the charged particle. There's a along magnetic field existing along B, along x-axis. and P strike a fixed target P on the axis for a minimum value of B naught. We will also strike target T if yes. So what they're saying that there is some target over which it is striking. Okay, see, it is moving like this, and how what will where the force will act on this? Let's suppose this charge is Q. So QV cross B, the force will act downwards. Okay, and its velocity force is acting downwards, and it's the component of this velocity is upwards. Some component of the velocity is upwards. Okay, some component of the velocity is upward, and some component is towards right. So is this right component? This component is going to change. Tell me.
Awesome.
Okay, this component will not change, and this because force is acting in this direction. So what happens? What happens? It will just move like a projectile, like this, because force is acting towards down. Force is acting towards down, so it will move like a projectile. Got it?
Yes.
So it will move like a projectile. Can you solve it now? Minimum value of B is equal to V naught. On the force, what is the value of force? Q V naught into B. Q V naught into B. Okay. And it pays like a target on x-axis for a minimum value of B naught. See, for other value, see, in this case, target is fixed. So at it can, this is range now. This is, let's suppose this range. This range is constant because target is fixed. Target is fixed. So when the range is, because there are two values of range. There are two values of range. Sorry, if there are for two inclination, the range is same. For two angles, the range is same. Okay, so it can also be like this. Also, it can be this, like also this by this using this trajectory also, it can hit the same target. Okay. But okay, this but they are the is what? See, u square sine 2 theta divided by g is f upon m. Okay, so u square m sine 2 theta divided by f. So see, m is constant, sine 2 theta is constant. So u square by f. So this value should remain unchanged. So if we increase the speed by root 2v, see, if we increase the speed by root 2v naught, root 2v naught. QV, oh wait, QV naught, oh wait. This is theta. So QV will be sine theta force is acting. Q will be sine theta force is acting. And both are correct. The answer is both are correct. How can it this be possible? Okay, see. Actually, the thing is that it is going like this. This velocity is v naught, and this b is existing towards right. This angle is theta. So force is not acting actually on this direction. Force is acting.
But in the solution, they're talking about pitch.
Send me. Okay, got it. So here the thing is that it is see, this is y-axis, and this is z-axis. So here the projectile is thrown on this, like behind the screen, with some inclination. So I have taken upwards. So it is thrown like this. So here, see, its movement would be like this. It will move like this. It is going to move like this. Okay, send me the solution. Send me the solution.
I've sent it.
For minimum value, it's collecting after one pitch. The pitch is hard. Okay, the thing, see, if the magnetic field is like this, so here the force is acting downwards. Okay, that is correct. Okay, force is acting downward, and what is the value of it? QVB sine theta. QVB sine theta. And in this case, the velocity is decreasing. So this velocity, v sine theta component. This is v naught. This is v naught, and v cos theta component is same. So it is moving like this. It will move like this. Like this. It will move like this. Okay. So QVB B cross B. Okay. So it will move like this, and so when it is striking, just see it at this point it is striking. At this point is nothing but a pitch. This distance, this point is nothing but the pitch, because here it is there, and these distances are pitches. These distances are pitches. Okay. Getting? So these distances are pitches. So yeah, and the formula of the pitches, v cos theta into time. Time is 2 pi m divided by qb. So this pitch should remain same. Means because either the pitch should be p. So for minimum value of b, because this is fixed, b value is coming out as v cos theta 2 pi m divided by q into p. Okay. So this value or pitch value is coming as this, and it has to strike the target. So either the pitch can be this. Let's suppose the distance is let's suppose target distance is x. So either pitch should be x should be a multiple of pitch n into p. Then only it will x should be n into p. So this should be the case. So x should be n into p, and pitch should be x divided by n. Okay, so pitch should be x divided by n, and for this, because cos theta is constant, 2 pi m is constant, q is constant. So v by b should be equal to 1 by n, where n is an integer. Okay. So it can be v by b. So the thing is that v should be greater. V by b should be this 1 by n. So v should be greater than. V can
any integer over here.
Yeah, no, v can be greater than. V by b should be 2, 3, 4. So like this. So v by b is 2. Then what is n can be 1, 2, 3, 4 like this. So n is 1. So n is 1. V is equal to b. Sorry, V is proportional to B. V is proportional to B. So it should be like this. So V can be proportional to B also. Okay. Let me see the other questions.
So, but why in the question they have specifically mentioned pitch can either be 1 or half? Is it just any other integer value that they took?
See. The particle is moving like this. Okay. So what is the value? Target can be over here. 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 Okay. So what is coming? N into P is equal to target distance. N into P is equal to target. So P is coming out X by N. Okay. It should follow this. So, and what is pitch? Pitch is 2 pi M divided by QB V cos theta. Okay. Okay. So see, now it should come because X is constant. Okay. So this should come some constant divided by a integer. Okay. So see, 2 pi M, 2 pi Q and M are constant. So, and cos theta is also constant. So this constant is into V by B, V naught by B, V by B. Okay. Okay. So see, now put the values. Put the value B is equal to 2 V naught. Because for when V is equal to V naught and B is equal to B naught, it is striking. It is striking the target. Okay. So, and now when V is equal to B is equal to 2 V naught. So we can find out the value like this. K by N is X by N is equal to K into V naught by B naught. So here what is K? Okay. So this okay. Now put like this, K into 2 V naught divided by 2 B naught. Is it this equation is valid now? This equality is valid now because this is the first equation. So we have to check if this equality is valid now, if we are putting the values of V and B. Okay, now put B as 2V naught, B as 2V naught. So X by N is equal to K, V as V naught and B as 2V naught. Tell me if this equality is valid now. Here N will be 2 only. Here let's suppose N is 1 and here N will be 2 only because N is an integer.
Sir, if in the option there was another option like 3B naught and V naught, then also it will be valid,
okay.
Right?
Yeah, correct. 3B naught and V naught also it will be valid. But if the option is given, yeah, if option is given V is equal to 2V naught and B is equal to V naught, then it will not be valid.
Because N becomes a fraction. Halfway.
Yeah, because N becomes a fraction. Got it?
Yes.
Okay. A long straight wire carrying current is bent into midpoint to form an angle of 45 degree. P distance from the point of bending is equal to okay. See, this is the point. The angle is 45 degree. And this is point P, where we have to calculate magnetic induction at this point. This distance is R. From this wire, from this section. See, from this straight section, this section the magnetic field is 0. 0. From this section, this this section, and we have to calculate only from this section. So what is the distance? Distance is this angle is 45 degree, and this is 90 degree. So this is R by root 2. Or wait. R by root 2, correct? R by root 2. Okay. So this is R by root 2. So it will be mu naught I divided by 2 pi R by root 2 sine alpha plus sine beta. Okay. Now see, what is sine alpha? Sine beta is 90.
Yes.
Getting it or not? Because the sine beta is this angle. Sine beta is this, this end is making with point P, this end, the infinity end. The infinity end is making infinity end is making 90 degree with this line,
Yes, sir.
And what is this end is making? This angle is making 45 degree.
45.
But that too in the same direction, so it will be minus 45.
Why is it minus?
Because see, one alpha we take generally in this direction, no? See, this is the wire and this is the point P. So one angle we take in opposite direction and one angle we take in the opposite direction. But here both the angles are in the same direction only.
Then how do we know it is in the same or opposite?
See, because this is the wire, this is the perpendicular line. See, this is the perpendicular line. So both are angular along this. So see, this is the perpendicular line here. So one angle is from in anti-clockwise and one angle is clockwise. So but here both the angles are anti-clockwise. Okay. Tell me, correct or not?
Yes, sir.
So it will be sine beta minus sine 45. So sine 90, this is sine 90. And so it will be 1 minus 1 by root. Okay. So it is coming out mu naught I divided by 2 pi r by root 2. And it is coming out root 2 minus 1 divided by 2 pi r mu naught I. Okay. This is the answer. Oh wait, 4 pi r. 4 pi r. Okay.
So can you give another example, like how to identify the angles? I think I'm facing a problem in that.
Okay. See. This is a wire. And we have to calculate electric field at this point. Okay. So see, normally the wire is what? Normally the wire is like this. We have to calculate angle at this point. So this angle is alpha and this angle is beta. Okay. But here this angle is alpha and this angle is beta. Both are the same direction. In this case, we will have to just do sine alpha plus sine beta. Both angle alpha and beta would be positive. Here also we have to do sine alpha plus sine beta. But here if sine alpha would be sine alpha plus sine beta, here sine alpha would be negative.
Sir, how do we know only alpha will be negative and not beta?
You have to just take the bigger angle. You have to just take bigger angle as positive and lower and the smaller angle as negative, because the answer should come positive. Answer should come positive because this expression sine alpha, because mu naught I upon 4 pi r is always positive. And you have to take in this bigger angle. The bigger angle, whichever is bigger angle, take that positive, and the whichever is lower angle, take that as negative. Okay. Got it?
Yes, sir.
Okay. Figure shows the various positions.
Sir, just have a doubt in one thing. This is an example. It was an illustration given in the book. I'll just send a picture of it.
Okay, send me.
So how to calculate the magnetic field of the center?
It's not getting downloaded. Why is it so? Tell me what are you asking?
How to find the magnetic field at point O?
At point O. See, this is A. This is B, this is B, and this is A. This is point O, and we have to find a magnetic field. See, tell me, the magnetic field due to all the wires. Let's suppose this is wire 1, this is 2, this is 3, this is 4. Okay, so due to all the wires would be in the same direction only, in the cross direction. Okay, so from this wire would be how much? This is alpha and this is beta. From this wire would be how much? Mu naught I divided by 4 pi. This distance is b by 2. Perpendicular distances. Okay, 4 pi b by 2. Sin alpha plus sin beta. What is this angle? Sin alpha and beta are the same. Okay, and sin alpha is this also alpha. See, so sin alpha is this is a square plus b square under root. This diagonal. Okay, so sin alpha is a divided by a square plus b square under root. Okay, sin beta is also same, so it will be 2. It will be 2 here. Got it? Tell me. So 2 and 2 and 4 gets cancelled out. So it is coming out mu naught I divided by pi into b. A divided by a square plus b square. Under root. Okay. This much is coming. If this is only from one wire, tell me from this wire, can we tell me in the same manner? In the same manner, can we tell me? Can we tell? It will be mu naught I divided by pi into a. B into a square plus b square under root. Just I have replaced a with b. A with b. Okay. So and tell me from this wire it will be again same. So it will be 2 and 2. Because see, the magnetic field due to this wire and this wire would be same. So I have just multiplied this expression by 2 and this expression also by 2. Got it? Okay, so next we just calculate mu naught I divided by pi 2. This we have taken common. And the thing is that is coming a square plus b square under root also common. And now a by b plus b by a. So it is ab. AB is LCM now. So AB is LCM and a square plus b square. This. Okay. So this will get cancelled out. So it is coming at 2 mu naught I divided by pi. A square plus b square divided by AB. Okay. Got it?
Yes, I got
it. Tell me if you got it. If there's some doubt, then you can ask me. Because why?
No, sir, I got it.
Got it?
Yes, sir.
Okay. And okay, this meridian also you want to see. Meridian question.
It's from 39.
39.
Yes, sir. Sir, for this, I saw two different methods. The formulas were kind of opposite. That's why I got confused.
In this case, the magnetic suspended angle of 30 is the magnetic meridian. The dip angle, the dip makes an angle with the horizontal real dip is.
Sir, in one thing, the tan of apparent dip angle was equal to cos theta multiplied by tan of real dip or something. The other thing, it was divided by cos theta, so I didn't understand.
Tip needle is vertical or horizontal? It is vertical, no?
What is that?
Dip needle is vertical or horizontal needle? It can move in, dip needle can move in the vertical plane or horizontal plane? It move in the vertical plane, no?
Sir, I forgot it.
Okay. These questions are actually simple also, but if you know the concept. Okay. This question I can tell you, if you want to learn, you can maybe you can collect this type of question in the next class, if you want, in some other session. Okay, if you are looking into this. Okay, because in this something I would need to explain. Okay, so let me check the other question. The current carrying the rod in the same plane, the more is towards the induced EMF. Yes, induced EMF. The wire is this, and the rod is this, and this having velocity v. Current is in this direction. This wire end is A and this end is B. Yeah, in this case, see, the rod is moving in this direction. So all the electrons are also moving in same direction, in this direction only, because rod is having free number of free electrons. So, and tell me, and which direction the force is acting on the rod, on the electrons? Magnetic field is lower, downwards, due to this wire, due to this wire. It will be towards down.
Would it be up?
For positive charges, it is up, but on electron, it will be down.
Yes, there is.
Okay, so negative charge is down and positive charge is up. Okay, so the potential difference is potential at A is higher and potential at B is lower, because A potential on A, the positive charge is placed. Okay.
Yes, sir.
Okay.
So the current direction is from A to B only, right?
Current will not flow because this is not a circuit. This is not a closed circuit. Only the electrons will accumulate over here, and positive charge will accumulate over here.
Okay.
Okay.
Sir, if it was a closed circuit, then
current would be going like this. Electron would be flowing like this, and current would be flowing like this.
Okay.
Okay, because electron would be flowing like this. So in this manner. Okay. Okay, see, an AC source is connected to a resistance and a capacitance. Okay, so in this case, what is the formula of current? What is the formula of current? What is the formula of current? Current formula is I naught sine. Let's suppose this formula is V naught sine omega t. So its formula, current formula would be sine omega t minus phi, where cos phi is equal to R by Z.
Should it be plus 5? Because it's capacity.
No, current. Okay, sorry, capacitance. Oh, correct. Nice. So it will be minus plus 5. Okay. Yeah, correct. So voltage would be I naught into R only. So voltage would be I is equal to I naught sine. So voltage would be V I naught into R sine omega t plus 5. Got it? And across capacitance, what will be the voltage? Can you tell me? Voltage would be current would be this current into XC. So it will be I naught XC and sine. See the phasor of voltage. The voltage is this. Let's suppose voltage is this, and current is leading by phi angle, and capacitor voltage leads the current, so it is 90-degree. This is VC. Okay.
Yeah, capacitor voltage lags.
Capacitor voltage lags. Okay, yeah, correct. Capacitor voltage lags. Sorry, capacitor voltage lag VC. So it is. So we can see that it is sine omega t. This angle is 90 minus phi. Okay, so this capacitance voltage is VC. We can write I naught into XC sine orbit. It will be V naught sine omega t. Because the time is about to up, I will take some time, and I am having another class also. So can we schedule in?
Sir, I'll ask for another session.
Huh?
Sir, I'll mail for another session.
Okay, if you can, if it is possible, then or otherwise you can also. I can tell you maybe if it is possible, then I can tell you in the chat also. If it is possible, then you can suggest a DNS session. Okay.
Yes, thank you.
Okay, Rashini. Okay. Then.